Alright, welcome to the second lecture for scheduling, and basically this is just an introduction to the project network. That is how we can use a network diagram to help us understand the schedule. There's mainly two things that we're trying to get out of this. Firstly, there are two types of schedules. A deterministic schedule, that means that we believe that all activities will take a particular time, no more or no less. I don't think there's an agreement that that's true in reality, that things will take a bit longer or a bit less, but the critical path method, or as you see there, CPM, first starts with the best guess of how long an activity will take, and then as the project progresses, it updates that information in the understanding that things change. The probabilistic approaches acknowledge up front that things might not be fully understood and there could be a best or a worst case scenario. And there are two types. One is project evaluation and review technique, PERT, and the other is a simulation. Look, the area of concern for us is simply the CPM, or the critical path method. So in this lecture I'm just going to introduce you to PERT, but that's about as far as we'll take it. And finally, both these techniques rely on drawing a project schedule as a network diagram. Okay, and the one that we mostly use these days is called an activity on network, or activity on node, I'm sorry. Activity on node is the network diagram that is most favoured. There used to be something called an activity on arc. It's gone out of favour, and there's good reason for it going out of favour. So I'm not going to introduce that to you. So historically, a couple of methods. The program evaluation review technique, PERT, and the critical path method were around for a while, but really they took off when, as people started building rockets to go to the moon or get out into space. What they were trying to do is crunch the schedule, do it as fast as possible. So they're looking for how many things could they possibly do at the same time, because that's the fastest way of completing the project. So they looked at what were the physical constraints about completing a rocket ship, things that that had to be completed. You couldn't add a turbo rocket booster or whatever, a solid, I can't remember what it's called now, but the rocket booster to the ship until you built other components of it. That's basically what both of these methods were designed for. Both of them go through a fairly similar process. That is, identify the activities, determine the order or the sequence, estimate the duration of those activities, and that gives you a schedule. We'll be only dealing with the critical path method, and that's a method used to estimate the minimum project duration and to determine the amount of scheduling flexibility in the project, so we can make changes to meet some of those external constraints that I've talked about before in the previous lecture, and we'll meet again in the subsequent lectures. So just quickly, a review of PERT, Program Evaluation Review Technique. It is exactly the same as CPM, Critical Path Method, except for instead of having one duration estimate, there are three. We have a pessimistic, that's the longest it could take, an optimistic, that's the fastest an activity could be completed, and finally a most likely. The technique then looks at what we call an expected value. We won't be going through that. You can skim through this part of your textbook. Critical path method, on the other hand, is the one that we're dealing with, and this is the most common technique. It's used to plan very large projects, things in the mining industry. Construction is particularly based on the critical path method. What isn't so much based on the critical path method are organisational change projects, and they tend to be a little bit like this critical path method, but leaning towards agile. Agile's not a big one for us in this preliminary unit, so we're mainly talking about maybe construction, engineering, construction projects, and larger projects. That uses a single time estimate for each activity, so we don't have a probabilistic schedule. And the critical path is the longest path through the entire schedule, so the longest sequence. All those activities along that longest sequence are what we call critical activities. It helps us determine, what the constraints are in the project and how quickly the project can be done. And as the lecture notes say here, and I was talking about before, it's ideally used in construction, mining, construction, and those sorts of things. Shipbuilders live on it. In fact, a lot of people that you might see in project management, in this part of project management, the scheduling, probably come out of the Navy or some other shipbuilding factory from around the world. So what does it look like? An activity on node. Okay, so we're really just talking about activity on node, and sometimes it's called the precedence diagramming method. That means what comes first, what comes directly before an activity can be completed. So we have here the activities such as B, so that's the activity, and that's the precedence. So B cannot be done until activity A is complete. This project is closed. It has one beginning, that's activity A, and one end, that's activity B. So the diagram method is a technique in which the schedule activities are represented by nodes, that's A, B, C, D, and are linked by paths or relationships to show the sequence in which this can be performed, in which the activities can be performed. And when we're doing our software, that's exactly what's being built behind the scenes, a project network diagram. So we're just finishing up now. There are 5 factors that limit the project completion. Obviously the order in which things can occur. If everything could be done simultaneously, we'd be finished as quickly as possible. But because some things need to occur before others, that extends the life of the project. The length or the duration of each activity affects the project schedule. So how quickly we can complete the project. So that's your basic 2 here, and that's what we're putting into the software, into the initial schedule. However, the length of activities and the order, or what the actual final schedule is limited by the resources that are available in the project, and particularly resources at specific points or times in the project. That can actually extend the life of the project. Okay, so that's your model. We talked about that before. That was what we call the initial pass, or a model. Then we bring in some reality. There might be some imposed dates. We might not have a particular piece of equipment until September the 1st, or whatever it happens to be. In which case, we've got to work around that real constraint. We've got to find a schedule that meets that constraint. That may have an effect on the overall completion time. And finally, cash flow, or just being able to finance the project, has a particular effect on the schedule. We can't do all the, we can't resource all the activities unless we can finance those activities. So some sort of periodic payment or some sort of return on investment might be required to complete subsequent stages of the project. And finally, those considerations, both the imposed dates and the cash flow, they affect when that project can be complete. We use the network diagram to get a model, and then we look at specific things that are in reality imposed on the project, and that gives us what we call our final schedule. So I thought we were going to have to, in the next lecture, or the next two lectures, we'll go through those processes, the time management processes, and look specifically at the best way of going about saying, okay, here's my initial model, here are the real constraints, therefore I have my final schedule. We'll call that a baseline.